China just landed on the moon's far side and brought back samples from a place NASA has never reached. Inside that lunar dust, they discovered fragments of a water-rich meteorite so rare, less than 1% are ever found on Earth. Why does this matter? Because this meteorite type carries up to 20% water locked in its minerals, and it could rewrite how we understand water delivery across our solar system. What if the moon holds more water than we ever imagined? Welcome to Space Update 24 Hours. Let's dive right in. For decades, one side of the moon has remained completely untouched by human explorers. Not because we didn't want to go there, but because getting there and coming back is one of the hardest challenges in space exploration. China just proved it's possible. On June 1st, 2024, China's Chang'e 6 lander touched down in the Apollo crater, nestled inside the massive South Pole Aitken Basin. This basin is one of the oldest impact craters in our entire solar system, spanning nearly a quarter of the moon's surface. The rocks here are over 4 billion years old, dating back to when our solar system was still forming. But here's the catch. This region never faces Earth, making real-time communication impossible without a relay satellite. That's exactly why NASA hasn't attempted it yet. So what makes the far side so different from the side we see every night? The answer lies in the moon's crust itself. While the near side is covered in dark, smooth plains formed by ancient volcanic activity, the far side is rugged, heavily cratered, and geologically ancient. Scientists believe material from the lunar mantle, the layer beneath the crust, was blasted to the surface when the Aitken Basin formed billions of years ago. If that's true, studying samples from this region could answer one of the biggest mysteries in planetary science. Why are the moon's two sides so fundamentally different? Chang'e 6 collected 1,935 grams of material using a robotic scoop and drill. That's roughly 68 ounces. Not much, but enough to change everything. After gathering the samples, the lander transferred them to an ascent vehicle that launched back into lunar orbit, rendezvoused with the return capsule, and brought the precious cargo safely back to Earth. China became the first nation in history to return samples from the moon's far side. Then came the real surprise. When researchers at the Chinese Academy of Sciences began analyzing the dust under high-powered microscopes, they found 7 tiny grains that didn't match anything from the moon or Earth. These fragments had the chemical fingerprint of Ci chondrites, the most water-rich meteorites in the solar system. These space rocks can contain up to 20% water locked inside their minerals, along with organic compounds and volatiles. On Earth, they're incredibly rare because they're so soft and porous that they usually burn up in our atmosphere. Less than 1% of meteorites found on Earth are Ci chondrites. But here's what shocks scientists. These fragile meteorites shouldn't survive impact on the moon either. Even without an atmosphere, objects crash into the lunar surface at such high velocities that they typically vaporize or melt on contact. Yet somehow, against all odds, microscopic traces of a Ci chondrite impact survive billions of years, preserved in the moon's dust like a cosmic time capsule. Lead researchers Qingtuan Wang and Xianhua Li sifted through more than 5,000 tiny fragments before identifying these 7 grains of olivine, a mineral common in both volcanic rocks and meteorites. Chemical and isotope analysis confirmed what seemed impossible. These particles came from an asteroid that struck the moon in the distant past, and fragments of that ancient impact melted, cooled rapidly, and remained intact in the regolith. This discovery isn't just about finding rare rocks, it's about water, and water changes everything. Both the United States and China are racing to establish permanent bases near the moon's south pole, where frozen water may exist in permanently shadowed craters. That water isn't just for drinking. It can be split into hydrogen and oxygen. Hydrogen for rocket fuel, oxygen for breathing. If we can extract and process water directly on the moon, we won't need to launch it from Earth at $10,000 per kilogram. Lunar water could become the gas station for deep space exploration. The discovery of Ci chondrite fragments suggests something even more profound. Meteorites like these may have delivered water and organic materials to both Earth and the moon billions of years ago. Scientists have theorized this for years, but now we have physical evidence from the lunar surface. The researchers estimate that up to 30% of meteorite fragments on the moon could be from water-rich chondrites, meaning the moon might actually preserve this material better than Earth does. But China isn't stopping with Chang'e 6. In 2026, Chang'e 7 will launch to explore the moon's south pole, searching for water ice beneath the surface. 2 years later, Chang'e 8 will test technologies that sound like science fiction. 3D printing structures from lunar regolith, extracting oxygen from rocks, and processing local materials into usable resources. This is called in situ resource utilization, and it's the key to building a self-sustaining lunar presence. By 2030, China plans to land its first astronauts on the moon. They've already tested their new two-part crewed spacecraft, the capsule and the lander module, earlier this year, and the tests were successful. By 2035, construction of the International Lunar Research Station will begin. This won't be a temporary outpost. China envisions a permanent base, possibly powered by a small nuclear reactor to survive the moon's 2-week-long nights when temperatures plunge to minus 173 degrees Celsius. Meanwhile, NASA's Artemis program has faced repeated delays. A December 2023 audit gave only a 70% chance of meeting a 2028 landing date. The White House's proposed 2026 budget included a 25% cut to NASA's funding, along with plans to phase out the SLS rocket and Orion spacecraft after Artemis 3. Political winds shift every election cycle, and space programs suffer the consequences. China doesn't face these constraints. Decisions are made behind closed doors, funding flows without public debate, and timelines extend or accelerate without congressional approval. Their space program operates on decades-long planning cycles under centralized control. Whether you see that as an advantage or a concern depends on your perspective, but one thing is undeniable. China is setting the pace. The technologies behind their lunar program, heavy-lift Long March 10 rockets, high-thrust propulsion systems, cislunar communications networks, all have dual-use potential. Chinese officials emphasize their space program is peaceful, but defense analysts note the growing overlap with the People's Liberation Army's strategic interests. Access to lunar resources, technological superiority, and long-term influence in space aren't just scientific goals. They're geopolitical leverage. NASA's approach relies heavily on private companies like SpaceX and Blue Origin to innovate faster and cut costs. It's a high-risk, high-reward strategy. If it works, it could revolutionize space exploration. If it doesn't, the United States risks falling behind in the most important domain of the 21st century. Two nations, two philosophies, two very different paths to the same destination. China is building for permanence, a lunar research station designed to last generations. The United States is building for reach, using the moon as a proving ground for Mars and beyond. One focuses on establishing presence. The other focuses on pushing boundaries. Right now, the scoreboard might not matter as much as the game being played, but in 10 years, when one nation has astronauts living and working on the moon, while the other is still dealing with budget cuts and program delays, the scoreboard will matter very much. The moon isn't just a scientific curiosity anymore. It's the next frontier of human civilization, the testing ground for survival beyond Earth, and the gateway to everything that comes after. Whoever masters the moon first will shape the rules for everything that follows, from asteroid mining to Mars colonization to permanent space habitats. And right now, China just found something NASA missed. 7 grains of dust that prove water-bearing meteorites bombarded the moon billions of years ago. 7 microscopic fragments that could unlock the secret to sustaining human life off Earth. So what does this really mean? 7 microscopic grains just prove the moon has been collecting water-bearing meteorites for billions of years, and we're only discovering them because China landed where no one else has. The far side isn't just unexplored territory, it's a cosmic library holding answers about how water spread through our early solar system. The nation that masters lunar water extraction won't just dominate moon exploration, they'll control the gateway to Mars and beyond. China found what NASA missed, not because NASA lacked technology, but because they haven't landed there yet. By 2035, China plans to have astronauts living in a permanent lunar base, extracting water and building from moon dust. That's their official timeline. backed by successful missions. The space race isn't about flags anymore. It's about presence, resources, and writing the rules for humanity's next chapter. And that chapter is being written on the far side right now. What do you think? Can NASA close the gap, or has China taken the lead? Drop your thoughts below. If this discovery fascinated you, smash that like button and share this video. Subscribe to Space Update 24 Hours and hit notifications so you never miss the stories shaping our journey beyond Earth. The moon is just the beginning.